according to the theory of evolution, the origin and development of the universe and all its systems can be explained solely on the basis of time, chance, and continuing processes. All living things have arisen from a single-celled organism. A second and opposing worldview is the concept of creation. According to the theory of creation, everything in the universe has come into being through the design, purpose, and deliberate acts of a supernatural creator. That means this creator created the universe, the earth, and all life on earth, including all types of plants and animals, as well as humans. On today's edition of Origins, find out how fearfully and wonderfully made you are.
Hello, my friends. Welcome to Origins. My name is Don Chapman, and it's my privilege to be your host. Origins is a forum where we take the evidence of science and use it to validate the truth of creation. We have with us back for part 2 of a wonderful show called Fearfully and Wonderfully Made, Dr. David Minton. And Dr. Minton, it was for many years a professor at the Medical School of Washington University in St. Louis, Missouri. And we've been talking with him about the whole process, the miraculous process of human birth. And I've just learned so much, and I hope you were able to be with us for part 1. But even if you weren't, part 2 is going to be full of information that I know God will use to bless you. Dr. Minton, welcome back.
Thank you, Don. It's good to be here.
I think we left that baby at about day 6 in the womb. Is that right?
That's right.
And one of the last things that you said was how important and how, I think you even used the word marvelous, the human placenta is. Can you tell us what it is and why it's so special?
Well, you know, I think the placenta is the most underrated organ in the body. It does such a marvelous job for us, and when the baby's born, everybody's so excited about the baby, we just throw the placenta away. It's very friable, it breaks down very quickly, it has almost no lifespan to it at all. And yet that amazing organ has supported that baby in a way that few people recognize. You know, it's one of the most, if not the most important organ in our body. We wouldn't be here without it. And yet none of us had our own placenta in our own body.
No, that's right.
The placenta, when you think about it, is rather like this plug here.
Okay.
You know, this could be hooked up to a computer or one of our TV cameras here, and those computers or cameras would not work if they weren't plugged in. And you think when you plug them in, there's just a couple of holes in the wall. It can't amount to much, but there's an entire power plant. And that's what the placenta really is. It's like the entire power plant. It does so many things. And we'll see some of the things that it does as we look into the marvelous development of the placenta. Let me head up to our board here.
I'm anxious to see what you have for us today.
Well, in diagrammatic form here, we have a structure called the blastocyst. The blastocyst is a structure that actually implants into the wall of the uterus. It does so at about 5-6 days after ovulation, and the baby just kind of waits for a while. Right in here, this part will be developing into the baby.
Okay.
But it has to wait until the plug-in and the power plant get set up. This is the wall of the uterus that you see over here on the right. And it has developed glands that make a sort of a fertile soil, if you will, into which this seed will implant. And there are many, many blood vessels in here. We see one right here. And these are blood vessels that are in the wall of the mother's uterus. Right away, we have a miracle on our hands. This tissue we're looking at here in green and what have you is a completely different individual, genetically distinct from the mother.
Right.
The mother's over here. This is the uterus. You've heard people say that the developing baby is part of the mother's body. Well, this just simply is not true, except in a trivial sense. This tissue, were you to inject it in the skin of the mother, would build an inflammatory response. In other words, the body would recognize it as foreign tissue and reject it. But one of the first miracles we encounter is as this blastocyst penetrates through the uterine wall, it is not rejected. In fact, it shouldn't even be able to burrow through the wall. Our body doesn't normally allow foreign tissue to just burrow right in.
Right.
But it does. And the cells that do the burrowing here are really pretty remarkable. These cells are called cytotrophoblast, and they fuse together to form what we call a giant cell. So if two cells fuse, you now have a little bigger cell with 2 nuclei. If another one fuses, you have 3 nuclei, another one 4, and so on until you get a really big cell. And this cell is called a syncytial cell, and the name changes from cytotrophoblast to syncytial trophoblast. And it is these syncytial trophoblast cells that will establish a relationship with the mother's blood supply so that the nutrients and gases in the mother's blood supply can be made available to the baby. By the way, it's also these cells of the syncytial trophoblast here that secrete a particular protein that circulates in the blood called human chorionic gonadotropin, and this is what these tests for whether the mother is pregnant or not are looking for.
Okay.
HCG. And that means that 6-7 days, right around in there, is about as early as you'd be able to pick up that the mother is in fact pregnant. Well, let's follow this sequence as this marvelous structure penetrates in. Here it's penetrated a little further. Note that many cells have fused out in this area here. We're getting really close to the blood vessel. Baby is pretty much still just biding its time over here. And notice it's penetrated quite deeply into the uterus. Eventually, it'll go right below the whole surface as it penetrates deeper. There it is, dropped below the surface of the uterus. You couldn't even see it from the inside of the uterus now. It's below.
It's actually burrowed its way in until it's totally buried in the uterus.
Absolutely. And now notice here's a blood vessel of the mother getting very close to the syncytial trophoblast mass here. A new feature that appears at this time is there are sort of empty chambers here inside the syncytial trophoblast. And these will become larger and eventually will be invaded with mother's blood. Let's take this the next step. Now we see that the syncytial trophoblast has done something really extraordinary and risky. It has literally eroded the ends of the arteries in the uterus of the mother. Eventually, 20 rather large arteries, nearly the size of lead pencils, will be having their ends literally truncated, and the blood of these arteries will shoot up into these spaces that you see here in the syncytial trophoblast. Now, you need to do this without leakage, naturally. Not only that, but this blood ought to clot.
Right.
Because it's encountering something that's not a blood vessel. It's encountering foreign tissue. We should have one massive clot. It'd be the end of life right there. It doesn't clot. The clotting mechanism is actually suppressed in the placenta.
It's amazing.
So mother's blood doesn't clot there. Notice baby is pretty much still biding its time here. Only when we have a good hookup and we get bathing of mother's blood can we really get seriously involved with the development of the baby. Well, we've jumped ahead here now to a 14-day embryo. This is still very early. We've reduced the magnification. The baby is beginning to develop here. We won't discuss what's going on there exactly, but the important thing is that we have mother's blood coming into this syncytial trophoblast, and at these points here, where you see red, baby's blood will come in, inside of blood vessels and get very close to mother's blood, being separated by this single huge cell mass called a syncytial trophoblast. Let's just see what that would look like. I'm going to draw. I'm not a great drawer, but we will try this. The baby is up here. The placenta will draw a line right across here, so blood vessels of the baby will come down to that. And down here is the uterus of the mother. The placenta will form 20 structures on average that sort of look like a tree. This is a tree upside down, and here the branches go right down into the uterine wall, and it goes out here. And that is one of 20 such trees that develop. These are the branches. Now the branches themselves will branch, and then the branches will branch, and so this will become almost like fuzz out here. The baby's blood vessels will run from the baby down into this structure, out, make a little capillary loop. I should have used a different color perhaps. Make a little capillary loop here and come back, and we'll have many such blood vessels. Mother's blood, on the other hand, will be out here. So the transfer will be between baby's blood and mother's blood across this surface, which is that single cell mass we call a syncytial trophoblast. With that in mind, let's just look at what this would be like. At 40 days, the placenta goes all the way around the baby. The baby is quite well developed at this point. We can see it in here. The amniotic fluid is out in here. And these little trees that we discussed before are various masses like this
that outer part
and
there.
this.
Okay.
And we're just seeing all the branches. Like looking at a tree or a bush with just many, many branches. Baby's blood would be running inside of all these little fuzzy branches. Mother's blood would be bathing.
It's all the black.
All this black area is mother's blood out here. So it can kind of filter down here among all the branches, right? All the way around. Now this is what we're going to do. We'll magnify that. This is one of the tiniest branches of the tree. Okay.
All right.
You get down these little finger-like processes. You need a microscope. In fact, this is an electron microscope to see this. And we notice that even the tiniest branches have little bumps on them too. We call those microvilli. The surface area is immense. In fact, if we were to unfold every little thing, all the branches, make it all flat, we'd probably be maybe half the size of a tennis court.
Wow.
With mother's blood on one side, baby's blood on the other. Now I've got something that's going to blow your socks off. In fact, if you don't have socks, you could lose a toenail on this one.
All right.
That entire surface is one cell.
That's all those fuzzy spots.
Everything. All that fuzz, if you straighten it out, it would be huge.
It's
like
one
a
cell.
Massive rug carpet.
It's amazing.
Is one cell. Now, millions and millions of nuclei in there.
Okay.
But one seamless cell. And all of the nutrients between mother and baby, all of the gases, everything, must go across this seamless cell. And they do so either passively by sort of soaking across, or they do so actively by having special pumps that pump them across. Let's just make an incision through this placental villus here. We're going to cut right there and see what it looks like on the inside. Out here is mother's blood. See, these are red blood cells out here. They belong to mom. All of these out here are mother's blood. But you see the red blood cells in here?
Yes, sir.
They're baby's blood. Yeah. And that's how close they get. Notice mother's blood here, baby's blood here, and in between the two is this little barrier here, and that's the seamless syncytial trophoblast that lines the entire surface of the placenta. Now, water can go across this passively. Sadly, alcohol can go across this passively. Yeah. That's why women who drink alcohol in large quantities when they're pregnant can actually have a baby born with fetal alcohol syndrome, because that alcohol goes right through into the baby, just like the baby we're drinking it. Also, recreational drugs. Many of them can pass right across this barrier passively, can get into the blood, and you get a crack baby, for example, on somebody with crack cocaine. Other things do not go across passively. I mean, the oxygen from the mother's blood goes to the baby's blood.
Okay.
And the baby has a special hemoglobin with a high affinity for oxygen, higher than the mother's blood does. There have been cases where the mother has died of asphyxiation, but the baby in the womb survived because it could use the limited oxygen more efficiently than mom. So this is just one of these little placental villas, of which there's just millions.
Now those can be two totally different blood types.
Yes. And so that's all separated out too, because there's no mixing of the blood.
It's not a mixing, it's a passing of nutrients and gases and things that are
Absolutely.
needed for life, but never the mixing.
Now, for example,
That's
a baby
amazing.
needs iron to make this blood, right?
Right.
That iron comes from the mother's blood, just
Right.
about like everything else does. To get the iron from the mother's blood to the baby's blood requires a special carrier protein, very, very complicated, that carries it across from one side to the other. And there are many, many other carrier proteins like this that are involved in getting nutrients from the mother's to the baby's blood.
So the blood supply stays totally separate, but the nutrients and the needed materials pass over.
That's right, back
That's
and
amazing.
forth.
Absolutely.
And you know, that placenta is doing everything. It's a kidney, it's a liver, it's an intestinal system, it's an endocrine system, it's all sorts of things to the mother, or to the baby. In fact, a baby can be born without kidneys, without a liver, without an intestinal tract, without a lung. In fact, most of these structures aren't functional anyway until the baby's born. The placenta does it all.
So that one organ, the placenta, basically does everything that all of our organs do collectively once we're born.
All the ones I mentioned, right.
No wonder you're excited about the placenta.
It's super organ. Now, I haven't told you the most incredible thing yet. This is almost beyond belief. When the baby's born, shortly thereafter, the placenta is ejected. And when the placenta is ejected, 20 major arteries going into this placenta are severed. Do you see a problem here?
Yeah, the mother could bleed to death.
Yeah, let's add to that problem. Remember what I said? The blood clotting mechanism is suppressed
Right.
in the mother's uterus at this time. So we have basically 20 severed arteries in a hemophiliac. This pretty much ought to be the end of life right here.
For the mother. Yeah.
Yes. And of course, no more babies after this, because you
Right.
couldn't have babies if you
That's
didn't
what
have
happened.
a solution. The solution obviously isn't clotting. It wouldn't work fast enough anyway. Each one of these places where the artery is severed when the placenta pulls away, there's a little muscular sphincter like a purse string that has a good sense to be on the mother's side, not on the baby's side, and it squeezes suddenly, clamping off all 20 arteries so that the net loss of blood is maybe a cupful in a normal delivery.
So a mother develops these little, help me here, muscles.
They are in the wall of the arteries of the mother,
Okay.
in the uterus,
Yeah.
and they stay open, thank the Lord,
Yeah.
until the uterus unplugs. It's been said that's the largest wound any human being ever gets and lives to tell the story, and that's the removal of the placenta from the uterine wall. And they all just clamp down, and if this were not so, the end of life.
Dr. Menton, you never cease to amaze me. We've got to take a break right now. Don't you go anywhere. We'll be back in just a minute to finish this incredible story of a journey we've all taken, the journey of birth, and how God has made us so marvelously. Don't go away. We'll be right back.
Creation versus evolution. You weigh the evidence. Eve, the mother of all, her DNA is remarkable. Over recent years, scientists have conducted a lot of research on DNA that's found in the mitochondria of a cell. Now, this DNA is only inherited through females. By comparing mutation or mistakes in the DNA of people worldwide, scientists came to a startling conclusion. It looks as if all people living today are descended from one woman. With the latest mutation data, the ancestral mother of all lived a mere 6,000 years ago. Today's guest on Origins, anatomist Dr. David Menton, is a speaker for Answers in Genesis. Audiences enjoy his well-illustrated presentations on a variety of fascinating topics. Many of these lectures are available on DVD. If you are interested in the subject of creation, you'll definitely want these for your own. Orders are being taken at 800-778-3390. You can also write to Answers in Genesis, P.O. Box 510, Hebron, Kentucky, 41048 or visit the website at www.answersingenesis.org.
We're back with Dr. David Minton, and we've been looking at how fearfully and wonderfully made we are. And Dr. Minton, when we left, you had just told us that the placenta was the super organ, and I think you convinced all of us that it was. What an incredible job it does while the baby is forming. But we've kind of gotten off the placenta. Let's get back to the baby.
Well, here's a baby that is at the 7th week. Here's a 7-week fetus. You can see still attached to the vessels that go to the placenta. We can see the little fingers and toes and the eyes and the ear.
Love it.
And this is only the 7th week.
Right.
Well, I'm going to jump all the way to the end here. Here's a baby in position for childbirth at full term, 9 months. Head down, ready to go. You can see the cord going to the placenta there. And Don, we run into another problem right here, and we're going to need another miracle. Have you heard about the fellow that built the boat in his basement and never checked the doorway?
Yeah.
Spent all that time and couldn't get the boat out. Well, this is a problem we have here. You see, there isn't any way on earth you're getting this baby out of there.
We got more baby than we got hold to get him out, don't we?
And it's not just because you can't stretch the tissues enough. The bones are too small.
Wow.
Let me show you what the problem is here. This is the pelvic bones, the hip bones. Go right across here. And the baby's head has to go right through here. And the simple fact is, the baby's head is not going to fit through there. That's it. That's pretty much the end of the story. Be the end of the human race. You'll never get a second chance to get this right if you're thinking about evolution. What happens is so extraordinary. There's a joint right here between the pubic bones, and there's a joint right here between the sacrum and the iliac, and another similar joint over here. Those 3 joints, this one, and this one, which are firmly held together with just a little bit of flexibility. Special enzyme collagenase is produced that dissolves not entirely, just partially, these ligaments, which allow the bones to flex and open just enough to let the baby's head through. And even then, the baby's head must turn like a key in a lock, just correctly, to fit through. And when the baby gets through, its problems are not over. It seems that while the baby was developing, it really didn't need much blood to go to the lungs because the lungs can't breathe anyway.
Right.
And so most of the blood, instead of going to the lungs, takes a little bypass right over into the aorta and down. You better come up with a solution for that just as soon as the baby's born. Once again, a little muscular sphincter closes off the bypass and for the first time sends the blood to the lungs. Same problem down here. The bloodstream has been largely bypassing the liver. Why? Because the placenta is a good liver with the help of the mother. But as soon as a baby's born, you must instantaneously at some point divert the blood from the bypass to go through the liver for the first time in quantity. And all of this happens through a rather amazing change in the blood circulation, so that we have circulation in the lungs, circulation in the liver, and it all happens almost instantaneously. And without it, everything we've been talking about up until now would have been pretty much a waste of time.
And we don't do any of that. God just does it.
Absolutely.
That's
It's
amazing.
just God's work, and what can we say? It's God's doing.
You know, I haven't had a chance to count how many times you use the word miracle in this lesson, but it truly is a cumulative miracle. It's a series of miracles from the very beginning. And thank you so much for the gift you've given us in
Thank
this
you, Don.
explanation.
My pleasure.
Friends, I hope that you have enjoyed as much as I have this awesome look into the work of God within a mother's womb to make each one of us. This is a miracle we've all experienced before we ever set feet in this world. And so I just pray that as you've watched the work of God in the making of the body, that it's touched your soul with a sense of awe for the greatness in the work of our God. I'd love to hear from you and see what you think of this marvelous material that Dr. Minton has shared with us. Will you write to me at Origins, Cornerstone Television, Wall, PA, 15148, or get a hold of us on the internet at originstv.org. You know, more than ever, as we wrap this show up today, I just want to remind you that it's God's view that He created you, and that should be your worldview too. God bless you until we see you next time.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 512 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins program number 512, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.